Howdy, AP PreCal. It's Miss Kosh. We are going to talk about using the unit circle, and I think I already have some videos on this, but I pulled a few ideas from someone who teaches AP PreCal and sandwiched it in between my ideas. So the notes, as you see me scrolling here, are now 3 pages. I'm pretty sure I have a video that covers the first page and the third page, but I need to make a video over the second page. So let's jump in. We'll do the second page right now. It's relating the unit circle and sine, cosine, and tangent, and that kind of stuff. So to begin with, we probably already talked about this, but I want to make sure I get it well in your brains. And that is that when the radius and the arc length are equivalent, the angle measure here that this opens up, so the measure of this angle is going to be 1 radian. And we probably talked about the fact that if I don't label it, its default is radian. So I can write out the word 1 radian, and sometimes that's helpful so you know what I'm talking about. But if I don't write the word radian, it's implied to be radian. And so over here, once on this one too, the radius and the arc length are the same, so theta is equal to 1 radian. We probably talked about this, but I'm going to remind you real fast, and that is that when I have an angle, that comes all the way over here, because, okay, and let me say this again. If my radius, I'm changing this now to 1. If my radius is 1, my circumference is equal to 2 pi r. I plug in 2 pi times 1 is just 2 pi. So that means the angle that's formed as I go all the way around is 2 pi radians. So be careful. Here's the whole reason I said this. I will have students who think, oh, 1 means 1 pi, and so this right here is the angle pi radians. And they think, oh, that's 1. Well, no, there's a difference between 1 radian over here and 1 pi radian, which is starting here, it goes 180 degrees. Pi radians is 180 degrees. Hopefully you already know that, but just wanted to make sure that it's really emphasized for you. Okay, so then they gave us this problem, and to be honest with you, I would have probably not given you the radius. I would expect you to know your Pythagorean triples, and just in case you haven't, you missed this somewhere else, the Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17. There are more, but these are the ones, and 7, 24, 25, and 21 years ago, a student named Liz Davis made up a song to help remember the Pythagorean triples in my class, and I still sing it, and it goes 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And these are great, keeping in mind, of course, that the hypotenuse is always those. So I probably, had I written this problem, I would not have included the radius. I would have told you the coordinates of this point are negative 12, 5, and so we went over 12 and up 5. And in this case, we don't usually, the sides of a triangle won't be negative, but the coordinates will be, depending on which quadrant. And so we can have negative sines and cosines and that kind of stuff. So here's our little right triangle. This has got a radius of 13, and it's a 5, 12, 13 triangle. So to find sine, it's opposite over hypotenuse. Cosine is adjacent over hypotenuse, and that was negative. And tangent is opposite over adjacent. I could put the negative at the bottom where it shows up right here, but I'm always afraid I'll lose it if it's in the bottom. So I tend to write it in the top or on the side. And that finds sine, cosine, and tangent of the angle that starts here at 0 and ends, it terminates on this little ray that passes through the point negative 12, 5. Okay, the other one, they've given us the coordinates negative 7 25ths and negative 24 25ths down here. And what this tells me is when I see this, this is my x-coordinate, and my x-coordinate right here is the sine value. I lied. Wow. Oh my goodness. The x-coordinate is the cosine, and I always think, okay, x comma y, we put our numbers alphabetical, it's cosine comma sine. Goodness gracious, I was wrong. Okay, so the x coordinate is the cosine, so this is negative 7 over 25, and the y coordinate is sine, it's negative 24 over 25, and the reason that I didn't do anything and use this over the tangent is because I know that if I do negative 7 over 25 squared, that's a squared, wow, plus negative 24 over 25 squared, I know I'm going to get 1. So I'm going to get 25 over 25, but let me show you what I'm talking about. This becomes 49 plus, what is that, 576 over 625. And when I add those together, I end up getting 625 over 625, which is 1. Okay, and so I knew that my hypotenuse was 1 because it was a 724-25 triangle. And that made my life easy. So this length here was 1. So each of these values, I can use the fact that the x value is cosine and the y value is sine when the hypotenuse is 1. And I've seen these ratios so many times I forgot to tell you that that's what's happening. Okay, so then your tangent, on this one I would probably say sine of theta over cosine of theta is equal to tangent of theta. And so the sine value we said was negative 24 over 25, and that needs to get divided by the cosine, which is negative 7 over 25. To divide fractions, I multiply by the reciprocal. Keep, change, flip. Is that right? Keep, flip, change? No, keep, change, flip. Okay, anyway. 25 over negative 7. The signs will cancel, the 25s will cancel, and I get 24 over 7 is my tangent value. Okay, and I think I have notes on this, or a video on this already. I will go find it. And the whole, okay, so maybe really quick, the reason we care about the unit circle is that it gives us all of our trig ratios. So if I look at just one triangle in here, now I'm just going to pretend that it's any, I'm picking the 30, 60, 90, but I don't have to. I'm picking pi over 6, but it could be anything. So if this is my angle, here's the x-coordinate, here's the y-coordinate. The unit circle has a radius of 1. So the reminder is that sine of theta would be y over 1, but I don't need to write that. It's just y. A cosine of theta is equal to x over 1, adjacent over hypotenuse, which is just x. And then tangent is the y value over the x value, which the y value was sine. The x value was cosine. So sine over cosine, this is also the change in y over the change in x is the slope. So we can use the slope of that line becomes the tangent of the angle. Well, maybe I don't really like to say equal slope, but this is slope that we're going to think about. So when I look at a problem like tangent of 2 pi over 3, so I know that 2 pi over 3 gets me here. I know the coordinates of that. I went over a little, so negative, and in the negative direction, up a lot, root 3 over 2. Tangent is the slope. This is, but it's also, I can do the y, root 3 over 2, divided by negative 1/2, or I can think of my slope values are either I have a slope of 0, I have an undefined slope, I have a slope of 1 or negative 1 in the other quadrants. I have a shallower slope of root 3 over 3 and a steeper slope of root 3. Okay, that's the steeper slope, but it's negative, so this is a negative root 3 is my tangent value. Let's do a sine one. So say I have sine of pi over 4. Okay, pi over 4 puts me here. The coordinates here are root 2 over 2, root 2 over 2. And so my sine value is the y, so that's just root 2 over 2. We'll do a cosine. 5 pi over 3 is going to be down here. Cosine is the x. We went over a little, so that's 1/2. Isn't that great? Okay, so with these, I can think about the coterminal angle. So I can subtract away, if I have 17 pi over 4, I can subtract away 8 pi over 4, which is 1 time around the unit circle, because 8 pi over 4 is 2 pi. That puts me where? That puts me at 17 minus 8 is 9 pi over 4. Oh, that's still too big. So I can take 9 pi over 4 and subtract away 8 pi over 4 again. And so this, the coterminal angle, is going to be pi over 4. What's sine of pi over 4? Root 2 over 2. And I'm done. All right, go practice. Good luck. The only way to learn this is to practice, practice.